We are FTC Team 12766 based out of Shoto, Oklahoma. Our team members we have 8 team members, 4 high schoolers and 4 middle schoolers. Those members consist of me. I'm Braden Chateau. I build. Philip Koblenz, who is a builder. Braden Blake, who is a CAD. He builds and he also helped program. Brianna Tweed, who is our main programmer. Caden Arlt, who builds. Trey Miller, who builds. Noah Daughtry, who does Engineering Notebook. And Braden Chepp, who also does Engineering Notebook.
Hello, I'm Trey Miller. I'm a builder and driver for Team 12766. Our shooting mechanism for this robot has gone through a few different phases. Our first phase was a flicker, much like this, where we had it on a motor and we were trying to flick the ring, but that didn't quite work because we did not have enough swing or spin. Our second shooter was a flywheel. We had this smooth wheel here with no grip whatsoever, and we could not get power for the robot to shoot. So we moved up to this a little bit rougher wheel with a little bit more grip, and we got power, but not quite enough. Our final wheel is this one, like this. We have a rough wheel with lots of grip. This wheel has plenty of power, just enough that we can comfortably shoot top shots. Our chute is a custom aluminum plate bent to fit the ring perfectly with this wheel on it.
Hi, I'm Philip Koblenz, and I'm going to talk about our intake system. The intake system is mostly made up of 3D printed brackets and PVC. We inserted surgical tubing into the PVC to help intake the rings. But we had a problem intaking the rings originally, so we added this extra bracket on the end that uses friction to drop down at the beginning of the match.
Hi, I'm Caden Arlt. I am a builder for Team 12766. This is the arm that we use now. It is made of 2020 extrusion. The claw is our third model. It is straighter because we didn't want to have to pick up the wobble goal and make it drop. This is the first one right here. It was too small, so we couldn't hit the wobble goal at the right angle. This is the second model. The hole is too close to the servo mount. So, the third model, we moved further out so we can get the wobble goal. This is the second arm. The arm was not good enough because it twisted. And we didn't want it to twist, so we just made it 2020 extrusion, like we have now.
Hi, my name is Braden Shutt, and I am a driver and part of the Engineering Notebook team. For this year's outreach, we are planning to take a community robot to community events, assorted community events in our community. We will also be remodeling a school facility for a better and improved workspace.
Hello, my name is Noah Daughtry, and I worked mainly on the Engineering Notebook for this year's season. In addition to our outreach, we have a scheduled meeting with our school's board to present this year's design. Also, we are presenting our robot to the elementary to show our capabilities and our design for this year's competition.
I'm Brianna Tweed, and I was the head programmer this year. Compared to last year, our programming has dramatically improved. Last year was my first year ever seeing any programming, so this year I came in knowing a lot more. This year I learned how to incorporate motor encoders, color sensors, and better commands, thus allowing us to have a more complex autonomous. We use 2 color sensors, one on each side, to read the ring's luminosity. If the luminosity reads a certain number, then it will either do autonomous A, B, or C. After that, after it runs and drops the wobble goal, it will try to shoot. This year we tried to learn how to use velocity for our shoot, but it ended up making the shoot less consistent than consistent.
Hi, my name is Braden Blake, and I'm the lead CAD designer for our team. We use Autodesk Fusion 360 to test our ideas and see if they will work. Our entire robot has been designed on CAD, and from the chassis to the shooting tray to the arm. For maneuverability, we use a holonomic drivetrain to line up our shots. We also have been able to create several components on CAD, such as the claw, the battery mount, and the intake mounts.